Students, welcome to Diamond Group of Institutions, NEET and K-CET online classes. Today we are going to discuss about the semiconductor devices. Here also we will discuss the total previous year's questions only. See the first question based on the transistor. Figure shows a DC voltage regulator circuit when a GINA diode of breakdown voltage 6 volt. So breakdown voltage VZ equal to 6 volt they given. If the unregulated input voltage varies between 10 volt to 16 volt, then what is the maximum GNR current? What is the maximum GNR current? We have to find. First, GNR voltage 6 volt they given, and next how much current is flowing through this load resistor we have to find. So this GNR diode and a load resistor connected parallel to each other. So the voltage drop across this one is equal to the voltage drop across this one. So GNR breakdown equal to the 6 volt. Here also voltage across this one, that means up to whenever the voltage is more than the breakdown, then current flow through this one. So now the potential here it is 6 volt, now here also 6 volt, then current flowing through the load resistor equal to IL equal to the VZ by RL. VZ that means GNR breakdown voltage given 6 volt by load resistance ka value is 4 kilo ohms. So 4K, 6 by 4 is 1.5 milliamperes. So the current passing through the load resistor is 1.5 milliamperes. Okay. Now, see now source. The source they mention here, source varying between the 10 volt to the 16 volt. Okay. So they are asking the maximum GNR current. So to maximum GNR current, we have to take the maximum input voltage. So maximum input voltage is the 16 volt, varying from 10 to 16 volt. So maximum voltage is the 16 volt. So here input equal to the voltage drop across the series resistance plus voltage drop across the GNR. Okay. So now input voltage equal to how much? 16. To get the maximum GNR diode, input voltage should be maximum 16, and the series voltage drop across the series resistor we have to find. Voltage drop across the GNR is the 6 volt. Now voltage drop across the GNR, series is the 10 volt. So we got here voltage drop across the series is the 10 volt. So if voltage drop across the series resistor is a 10 volt, then find the current across this one. Current across the series resistance IS equal to the voltage drop by resistance. Voltage drop across the series is 10 volt. Series resistance ka value is 2 kilo ohm. Now we will get the 5 milliamperes. So current flowing through the load resistor is the 1.5 milliampere. Current flowing through the series resistance is the 5 milliamperes. So we know the input current, that means the total current equal to the IS. Here this current will be divided into the two parts. IS will divide into IZ and IL. So IS equal to the IZ plus IL. From this IZ equal to the IS minus IL. So IS value we know, the current flowing through the series resistance 5 milliampere, current flowing through the load resistance is 1.5 milliampere. Then the current flowing through the GNR diode is a 3.5 milliampere. So the maximum current flowing through the GNR diode is a 3.5 milliamperes. Okay, remember this 3.5 milliampere. D is the right option. In this way solve the question. This is based on the GNR diode. The next, see the next question. The transfer characteristic wave curve of a transistor based question having input and output resistances. So okay, so output resistance they given how much? 100 kilo ohms, and input resistance they given how much? 100 ohm. Okay, now this value is given respectively shown. The voltage and power gain are respectively. We have to find the voltage and power gain we have to find. So they given the curve here. See now. So on y-axis they are taking the collector current, and the y-axis they are taking the base current. Collector current is in terms of the milliamperes and base current is in terms of the microamperes. Okay, if we find the slope of this one, slope is nothing but the y coordinate by the x coordinate. So slope equal to the IC by IB. Y coordinate is the IC and x is the IB. IC by IB. IC is the collector current and IB is the base current. So IC is the output current by, suppose here IC is the output current and IB is the input current. Then output current by input current, here IC is the output current and IB is the input current for the common emitter configuration. Okay, this is showing the common emitter configuration. That means slope of this graph will give the current gain of the common emitter configuration. So from that, current gain equal to the IC by IB. Slope is nothing but the current gain, beta equal to the IC by IB. So IC value. So any term we can take same value we will get. So 100 by suppose either IC value is 5 milliampere by 100. First one is indicating the IB and the second one is indicating the IC, x coordinate and y coordinate. So 5 milliamperes by 100 microamperes equal to 50. Other you can take this one also, 10 by 200 also 50, 15 by 300. Every case we will get the same value. Now current gain value equal to the 50 we got, but they are asking the voltage gain and power gain. In common emitter configuration, voltage gain and current gain formulas, voltage gain and power gain formulas are given in the first video. Once watch that first video also. So voltage gain equal to, we can write it as the voltage equal to the V equal to I into 1. So voltage gain equal to current gain into resistance gain. Current gain is the beta, resistance gain is nothing but output resistance by the input resistance. Okay, now beta value we found already, current gain 50 into our output voltage is 100 kilo ohm, input voltage is 100 will be cancelled, 50 into K, 10 power 3. So 50 into 10 power 3 we can write it as a 5 into 10 power 4. Voltage gain we got. Now we have to find the power gain. Power gain equal to, we can write it as the I square R. Okay, current gain square into resistance gain. So current gain square into resistance gain is R out by Rn. So beta value we found already 50 into 50 square meter 2500 into R out value is the 100k and Rn value is 100. We will get the 2.5 into 10 power 6 value. Voltage gain equal to, we can write otherwise voltage power gain equal to the voltage gain into current gain. From that also we will get the answer. Okay, now answer is voltage gain is 5 into 10 power 4 and power gain is 2.5 into 10 power 6. D is the right option. Like this we have to solve the question. This is the last year mains in 2019 they asked the mains exam. Now the truth table for a circuit given in the figure. So don't underestimate this type of questions, very important, and do it carefully. Okay, by using the De Morgan's equations we will get it very easily. So see, now this is the circuit diagram they given. Okay, these are the options given. First, what is the Y we have to find. So see, now this is the output of, this is the OR gate and this one is the NAND gate. Okay, this is the NAND gate. Okay, so OR gate ka output I am assuming that X. So X equal to what? A plus B. Okay, OR gate ka output is A plus B. Now Y is the output of the NAND gate. What are the inputs of the NAND gate? A is the one input, second input is the output of the OR gate. So Y equal to the A and X is nothing but the A plus B, and now function is multiplication, A into A plus B, and complement is there, then and plus not will become NAND. So whole complement is there. So A into A plus B whole complement. This is the output of the NAND gate. Now follow the D programs. So A into A. So I am multiplying inside A into A plus A into B. AB. Okay. A into A will cut the A only. Okay. Next. A into A is A into plus AB. So in these two terms, A is the common, taking A 1 plus B. So from this Boolean algebra, 1 plus B will give the 1 only. If beta B equal to 0, 1 plus 0, 1 only. B equal to 1, 1 plus 1 equal to 1. Okay, so 1 plus something will give the 1 only. So 1 plus beta value B equal to the 1. So A into 1, A only. A complement. That means the output of the NAND gate. Okay, now the output of this circuit will give the A complement. So see the A options. 0 complement 1. Okay, 0 complement 1. 1 complement, this 1 they given. This is the wrong option. Here 0 complement 1. 0 complement 0 they given wrong option. So 0 complement 1. 0 complement 1. 1 complement 0. 1 complement 0. So this is the right option. Like this we have to check and we can solve very easily. And next question, see now the logic gate equivalent to the given logic circuit is. Okay, now they given the one circuit that is equivalent to the which logic gate they are asking. So see now here we have the two NOT gates. This is the NOT gate, this is the NOT gate, and this is the NAND gate. Okay, na NAND gate we have. So first write out. So output of the NOT gate is A is the input, output is the A complement. B is the input to this NOT gate, output is the B complement. Okay, so A complement, B complement, both are inputs to the NAND gate. So output of the NAND gate Y equal to the A dot B dot A dot B dot all complement. A complement dot B complement all complement. This is the output of the NAND gate. Okay. So now X plus Y all complement is there from the De Morgan's theorem. We can write it as x complement dot y complement, but here we have x complement plus y complement, whole complement is there, we can write it as x complement already is there, next whole complement dot y complement whole. Okay, same way I written here. Here they given the product is there, same way I am going to write x dot y whole complement is there, we can write it as x complement plus y complement. Suppose x complement dot y complement whole complement is there, we can write it as x double complement plus y double complement. These are the rules from the De Morgan's theorem. So based on that one I written here a complement dot b complement whole complement is there, we can write it as a complement a double complement plus b double complement. A double complement is equal to the a complement whole complement equal to the a only, a double complement equal to the a only, b double complement equal to the b only. So now we got y equal to the a plus b. So a plus b are the inputs, sum of the inputs will give the OR gate. So C is the right option. In this way we have to solve the questions. Okay, see the next problem, fifth one. An NPN transistor operates as common emitter amplifier with a power gain of 60 dB. Here they given the power gain in terms of the decibels. The input circuit resistance is 100 ohms. So input circuit resistance is 100 ohms and the output resistance is 10 kilo ohm. The common emitter current gain beta is, current gain we have to find. First this is decibels they given. So if they given the decibels, to find out the power gain, the formula is AP equal to the power gain equal to the 10 log base 10 P output by P input. So now in decibels 60 equal to 10 log 10 P naught by Pi. So now 0, this 0 will be cancelled, this 10 will go, this is 10 power 6 we will get, P naught by Pi equal to the 10 power 6. This is the from mathematics, you can do it very easily. So now power gain equal to how much? 10 power 6. We are converting decibel, we are changing into the, here they given the decibels now, by using the formula we are finding the power gain is 10 power 6. And the next we know already relationship between the power gain and the current gain. So power gain equal to the beta square into R output by R input. Okay now. So already previous problem we discussed that one. So power gain value is 10 power 6 into beta square, output value resistance 10 kilo ohm, 10 kilo ohm means 10 into 10 power 3, by input is 100 ohm, 100 ohm, okay. 10 into 10 power 3 means 10 power 4, 10 power 4 by 100 means 10 square, so we cancel it, we will get the 10 square, okay. This 10 square send this side, then beta square equal 10 power 6 by 10 square, 10 power 6 by 10 square we will get 10 power 4, beta square is 10 power 4, beta equal to the 10 square, so 10 square is the right answer. A option is the right answer. In this way solve the problem. If they give the power gain value in the decibels, follow this procedure and follow the as usually use the formula. Okay, and then next we come to see the next question. An NPN transistor is used in common emitter configuration with 1 kilo ohm load resistance. Load resistance they given 1 kilo ohm, I have written here also, and signal voltage of 10 millivolt is applied across the base emitter. So base emitter is the input junction here. So now input voltage equal to how much? 10 millivolt. Okay. This produces a 3 milliampere change in the collector current. Change in the collector current they given 3 milliamperes, and the change in the collector current and 15 microampere change in the base current. Okay, base current may change is the 15 microamperes of the amplifier. The input resistance and voltage gain are input resistance, voltage gain they are asking. Use the formulas, find it. So input resistance we have to find now, input voltage we know, and input current change in the input also we know. So input voltage equal to input resistance equal to the input current by input voltage by input current. Input voltage is 10 millivolt, input current is 15 microamperes, 15 into 10 power minus 6. Then input resistance we got 0.67 kilo ohms. Simplify this one. Okay, they are asking next one is the voltage gain. Voltage gain equal to, we have the formula current gain into resistance gain, RL by RA. But voltage gain, current gain not given. Current gain ka formula output current by input current into RL by RA. Output change in the output current given, change in the input current given. So change in the output current is nothing but the IC equal to 3 milliampere, 3 into 10 power minus 3. Input current, change in the input current is 15 microamperes, 15 into 10 power minus 6. Output resistance RL equal to 1 kilo ohm, 1 kilo, and input resistance we found already 0.67 kilo ohm. So simplify it, we will get the answer. Voltage gain equal to the 300. Input resistance is 0.67 kilo ohm, voltage gain equal to the 300. So answer is 0.67 kilo ohm and 300. C option is the right answer. See, easy question. Okay, na? And next, a common emitter amplifier circuit built using a NPN transistor is shown. Its DC current gain is 250. DC current gain. Okay, current gain equal to the how much they given? 250 they given. Okay, and RC, load resistor or output resistor or collector resistor, that is 1 kilo ohm they given RC, and VCC is the 10 volt external voltage supply, 10 volt to the collector junction. What is the minimum base current for VCE to reach saturation? Okay, na? To reach the saturation, what is the minimum base current they are asking. So see now, they given the current gain formula already we know, output current by input current. So this is the common emitter amplifier. Output current is the collector current, input current is the base current. From that, beta equal to IC by IB. And next, we know these equations, input equation and output equation, once you see the first video. So here output equation is VCE equal to VCC minus ICRC. In saturation means both are in the forward bias. Okay, na? Input junction and output junction both are in the forward bias. Then the VCE will become, that means here VCE will become minimum, that means it is, whenever it is in the saturation condition, this VCE almost equal to the 0. Okay, na? Then it will act as a on switch. Okay, na? So saturation condition on switch, cutoff region off switch, na? So on switch and VCE almost equal to the 0. So saturation condition if they given, then take the VCE equal to the 0. Okay, now if we take VC equal to 0, then we will get VCC equal to ICRC, IC equal to VCC by RC. Okay, from this, why I am finding the IC means beta value they given, they are asking the base current, we have to find the IC value, collector current. That's why I am finding here collector current. IC equal to what I am getting? VCC by RC. VCC value they given 10 volt, 10 by RC value. So resistance value. Okay, collector resistance value 1 kilo ohm. Then simplify, we will get the 10 milliamperes current. IC is the. Now substitute in this formula, we will get the IB value. They are asking the base current only, na? So base current IB equal to the IC by beta. IC by beta. IC value is 10 milliamperes. Beta value is 250 they given already. So substitute and simplify it, we will get the 40 microamperes. So 40 microamperes is the right answer. Okay, na? If they give for saturation, to reach the saturation means take the VCE equal to the 0. Remember this problem. And the next question, the output of the given logic circuit is, okay, options they given, and this is the logic circuit they given, they are asking the output. Okay, so this is the NAND gate, this is also NAND gate, this is the OR gate, and this is the NAND gate. Okay, here 3 NAND gates are there, 1 OR gate is there. First see now, A and B are giving inputs to the this NAND gate, and we are getting the output as a P. So what is the output of this first NAND gate? I am going to find. First NAND gate ka output is P equal to A and B are the input. AND gate ka input is, output is A, B. And NAND gate na complement, A, B complement. This is the output of the first NAND gate. Come to see the second NAND gate. Okay, second NAND gate ka input is A, and one more input is the output of the first NAND gate. So the output of the second NAND gate Q equal to the input A, and input of one more input is AB complement. So AND function is A dot AB complement, and a complement is then a whole complement. Okay, then simplify this one. Already I said to you, A dot AB complement. So how can we write x dot y complement is there? We can write as x complement plus y complement. Na? So A complement plus AB complement whole complement. So A complement plus AB double complement is there, na? We will get the AB only. So this is the output of the second NAND gate. Okay, next come to see the OR gate. Okay, OR gate ka output is R only. I given the sign R. So this we have to find. One input is B, one more input is the output of the first NAND gate. Okay, so OR gate function is the sum. Okay, addition. So output of the OR gate is, one input is B plus output of this first NAND gate is the AB complement. AB complement. So here B plus AB complement we can write it as, already we know AB complement we can write it as A complement plus B complement. So I am writing A complement plus B complement. Either B plus B complement, so remember that value, B plus B complement value equal to the 1. So 1 plus A complement, okay na? So 1 plus A complement equal to the 1 only. So now output of the OR gate is a 1, output of the second NAND gate is the A complement plus AB. Now these two are inputs to the third NAND gate, okay? Y we will get, so Y equal to the, so Q is nothing but A complement plus AB, R is nothing but 1, so AND function A complement plus AB dot 1, complement is there na, so whole complement. So this we can write it as, I said already, A dot B complement, A dot B complement, A complement plus B complement na, this complement, A complement plus AB whole complement plus 1 key complement, okay? Now A plus B form there na, A plus B is there, then what we can write, A plus B complement is there, A complement dot B complement we can write it. So now I am going to write this one, A complement whole complement dot AB complement plus 1 complement ka 0 is 0. Now A double complement is nothing but AB complement we can write it as, AB complement we can write it as A complement plus B complement. Now multiply inside, A into A complement will give the 0, A into B complement, A into B complement. So 0 plus something, A into B complement, A into B complement, A is the right option. In this way we have to solve the problem. This is the very important question, 2019 in mains this question asked. Okay, see the next question, 9th question. The circuit shown below contains two ideal diodes, each with forward resistance of 50 ohm. So forward resistance is 50 ohm. The battery voltage is 6 volt. So battery voltage is 6 volt. The current through the 100 ohm resistance is 100 ohm resistance. They are asking the current. Okay, once you see now here, this diode, this is the P side, N side, P side, N side. So now P is connected to positive, N is connected to negative. So D1 is in the forward bias. So N is connected to positive, P is connected to negative. So D2 is in the reverse bias. So now it is in the reverse bias, then it will act as a open. If it is in the forward bias, it will act as a short circuit. Okay, now see I am redrawing this one. This is operating, okay, and this one is in the open circuit. Remove this branch. So then after removing this branch, we will get the equivalent resistance, equivalent circuit is, so like this. So this is the D1 diode, and here we have the 150 ohm, and this is the 100 ohm, and here the voltage is 6 volt. This is the after removing this branch. Okay, now why we are removing this one means this diode is in the reverse bias. If it is reverse bias, then open circuit. So then this diode is in the forward bias, and this diode is offering the 50 ohm resistance. Okay, this diode is offering the 50 ohm resistance. Now see the diode offering 50 ohm resistance, and this is the 150 ohm resistance, this is the 100 ohm. All these are in the series combination. Then the equivalent resistance of the circuit. So the equivalent resistance of the circuit equal to the 50 ohm plus 150 ohm plus 100 ohm. That will get 300 ohm. What is the voltage supplied to this resistors means 6 volt. So voltage is the 6 volt. Now they are asking the question, the current through the 100 ohm resistor, the current through the 100 ohm resistor. All these are connected in the series. The current flowing through the all the components is same. So now the current I is, current flowing through the circuit is I equal to the V by R equivalent. Okay, na? So V is the 6 and 6 volt, R equivalent is the 300 ohm, then we will get 0.02 amperes. So the current flowing through the circuit is a 0.02 amperes. So all the components are connected in the series. So same amount of the current is flowing through the 100 ohm resistor also. Now the current flowing through the 100 ohm resistor is the 0.02 amperes. So B option is the right answer. Now come to see the next question. The electrical conductivity of semiconductor increases when electromagnetic radiation of wavelength is shorter than the 2480 nanometer. If wavelength is shorter than this one, then electrical conductivity increases. So the band gap for this, okay, band gap we have to find. Band gap So now they given the minimum wavelength. Minimum wavelength equal to how much? 2480 nanometers. Convert into the angstroms, then 24800 angstrom. Just keep the one more zero. 24800 angstrom. They are asking the band gap in electrovolts. Band gap is nothing but the energy gap. Energy gap formula E equal to the h mu or hc by lambda. They given wavelength na, so hc by lambda. So I am giving the value. If the lambda is in terms of the angstroms, then hc value is 12,375. So remember this formula, easy for the simplification. So 12,375 by wavelength in terms of the angstroms. So 12,375 by lambda in terms of the angstroms is nothing but 24,800. So 24,800. If we simplify this one, almost we will get the energy gap value is 0.5 electrovolt. So the unit of this one is a electrovolt. Okay, so energy gap ka or band gap ka value is 0.5 electrovolt. C option is the right answer. Very easy question this one. Okay, next to come to C. So the forward biased diode connection is, they given the 4 options. In these 4 diodes, which is in the forward bias, we have to identify that one. Okay, so now here we can expect this type of questions in the NEET exam. Okay, now the question is, once you see forward bias means P connect to the high potential and N connect to the low potential. So this is the P and N. This is the P and this is the N. P and N. This is the P and N. Okay. See, now P is connected to the plus 2 volt and N is connected to the minus 2 volt there. Okay, na? Okay. So next here P connected to the minus 3 volt and N connected to the minus 3 volt. Here here P connected to the plus 2 volts and N connected to the 1 volt, and P connected to the minus 2 volt, N connected to the plus 2 volt. In these 4 options, in which option P connected to the high potential and N connected to the low potential, we have to see. Here both are, this is the plus 2 volt and minus 2 volt, sorry, this is the minus 2 volt here, C option. So here plus 2 volt means high potential, N is minus 2 volt means low potential. Okay, so this is in the forward bias. Okay, P at the high potential, N at the low potential. Now come to C, minus 3, minus 3, both are at the same potential, not in the forward bias. This is minus, this is at the low, P at the low potential, N at the high potential, this is also not in the forward bias. And P at the low potential, N is at the high potential, this is also not in the forward bias. Option A is the right answer. So while you are attempting this type of questions, carefully observe the P side voltage and N side voltage and take the answer. We can expect this type of questions in the NEET exam. Okay, so all these are the previous year's questions, and concentrate on these questions and practice more. You can get easily from these semiconductor devices, we can expect 3 or more questions in the NEET exam, and that also very easy questions we will get. So practice more and more. Thank you.